let me start by explaining what this expression ANOVA means, and the reason for that is that actually behind that name is a little bit of the beginning of understanding how the method works. ANOVA is actually an acronym, as you probably have already guessed, but it's a bit of an unusual acronym in the sense that most acronyms, in most acronyms, each letter stands for one word. Here we're dealing actually with just three words, okay? And the three words are analysis of variance. Okay. So I guess statisticians decided that OV was not a very good acronym to use, and so they decided to attach another couple of letters to make it sound a little bit less scary. Now, why do we call this method analysis of variance? Well, because it's a method that uses the variance. Now, what is the variance? You may remember that the variance is the square of the standard deviation. Remember, it is a measure of variability which is used preferentially by statisticians, or people who do theoretical work. So when you have to develop a new method, you have to do it theoretically first. So it uses the variance to test for a difference of means. So one important thing to realize is that ANOVA, despite its name, does not test variance. It only uses it. It analyzes variance in order to try and make some conclusion about the difference of means, which of course leads me to point out once again and more explicitly that the purpose of ANOVA is to compare the means of three or more groups, and it does that by analyzing the variance. Now, because it uses means or compares means, it means that we're going to be dealing with a numerical variable, because of course any numerical variable which is nominal or ordinal, well, the mean we may also be able to compute it, but it doesn't make a lot of sense. Okay, but also one thing to keep in mind is that unlike the t-test, for which we said ordinal variables may be acceptable in some situations, for ANOVA is much more finicky than that. So you don't want to use ANOVA for ordinal variables. In fact, we're going to see later, soon that ANOVA is more finicky from all points of view. Okay? Now, let's see how analysis of variance then, or ANOVA, actually uses the variance to make some conclusions about the means. So here is how ANOVA works. Okay, so remember, we're trying to compare several groups. Let's say that we're comparing four groups, and the four groups look like this. Well, of course, I'm showing you the four groups in terms of box plots, which means that I'm actually showing the median, not the mean. But once again, I'm trying to give you a little bit of a flavor. And because the box plots uses the median, well, that's okay. Don't worry about it too much. So let's say that these four groups, well, from what we see, their medians are not exactly the same, but they're pretty close, right? And so we can assume that in this situation the mean would be pretty close. Okay, again, I'm not running through the test as it should be done, just giving you a flavor. So if we have four groups with roughly the same mean, if I look at the variability of all the data put together, so if I put together data from all four groups, I'm going to end up with a box plot that does not look much different from each of the individual four, right? In terms of variability, sure, it's going to go from the minimum of the smallest minimum to the largest maximum, and something in between also is going to be combined, but overall it looks pretty similar. So what that means is that if we have four groups with equal means, that implies the overall variability of the whole group to put together is going to be roughly equal to the variability of each of the groups. Okay? But let's say that these four groups actually end up being quite different in terms of their means. So one group actually is a lot less than the other one, some are somewhere in between, and so on. But now again, if you look at these four groups, they look quite different. Well, if we put all the data together, what would the box plot look like? Well, of course, it would look like more like something like this, right? So that means that the variability of the whole group will look quite different from the variability of each of the individual groups. And this is what ANOVA actually exploits. So what it tries to do is says, okay, let's compare the variability of the whole group to that of the individual groups. If the overall variability is not the same as the group variability, the variability of each of the groups, then it must mean that the means are unequal. Now, I hope I've convinced you with this little visual demonstration, but I hope also that you have noticed that I've used a little bit of a sleight of hands, because in order for all of this to work, okay, it is very, very important that the variability of each of the groups are roughly the same. if some of the groups have a much different variability from the rest of the groups, that of course is going to affect the variability of the overall, and it's going to affect the way we compare the overall group to each of the individual groups and so on. It's going to throw the whole procedure out for the loop. So here we have another requirement, another basic fact that must be true in order for the procedure to work. So we're going to go back to it later once we talk about requirements, but notice you may want to review again how I thought through the process, and notice that again this is the whole process is going to fall down if the groups do not have the same variability.